Hello everyone, this is me Kalam Hussein here, and I am going to present my practicum 11 of Max second semester here. And here are the questions which have been given and determine the output. So let's dive into the first question. Onto the first one, which is network packet delay analysis. In a computer network, the Laplace transform presentation of a packet delay in a communication channel is given by f of s is equal to 1 by s plus 5. Reconstruct the time domain delay signal f of t using the inverse Laplace transform to analyze how the delay decays over time. So on to the code, which is we are for the first one. We are importing the sim p by SSP, and after that we are defining the symbols, which is s t and s, which is equal to sp dot symbols ts, and we are applying the Laplace domain function, which is f is equal to 1 by s plus 5, and then after that we are applying the inverse Laplace transform f is equal to sp dot inverse Laplace transform f s and t, and after that we are removing a heavy side T F clean is equal to have replace SP dot heavy side T1, and after that we are printing the time domain signal packet delay response, and after that we are printing out the F of clean and onto the output, which is determining as the time domain signal is exponential of minus 5 of t. And on to the second question, which is CPU load response computing. In a cloud computing environment, the Laplace domain model of a CPU load variation is represented as f of s is equal to 4 by s square plus 16. Determine the time domain CPU load response ft using the Laplace transform, inverse Laplace transform. On to the second one, we are applying the first one. We are applying the import sim py ssp, and after that we are defining symbols t comma s is equal to sp dot symbols t of s, and after that we are applying that Laplace domain function f is equal to 4 by s square plus 16, which is already given in the question below, and after that we are applying the inverse Laplace transform f is equal to sp the inverse Laplace transform f of f comma s comma t, and we are removing the heavy side of t. We have clean is equal to f s replace sp dot heavy side t of 1, and after that we are printing the time domain CPU load signal, and after that we are printing out the f clean, and on to the output, which provides the first as a time domain CPU signal load signal, and after that it will print the output, which is a sine of 4t, because it is basically these is an applied accordingly to the code, and on to the third one, which is um, data transmission signal reconstruction. During digital communication, a Laplace domain representation of a transmitted signal is a f of s is equal to 2 by s square. Reconstruct the original time domain transmission signal f of t using the inverse Laplace transform, and on to we are diving onto code, which is we are applying a input as in py as sp, and after that we are defining the symbols t and s is equal to sp dot symbols, and after that we are applying the for Laplace domain function, which is f is equal to 2 by s square, and after that we are applying the inverse Laplace transform, which is f is equal to sp inverse Laplace transform f comma s comma t, and after that we are removing the heavy side t. This f clean is equal to f dot replace bracket sp dot heavy side t comma 1, and after that we are printing on the reconstructed dynamic transmission signal, and after that we are printing out f clean, which is 2 by basically these three are applied using the inverse values, which is similar to the formulas of Laplace domain functions. So yeah, these are the codes which I determined and gave the output for. So let's go through and check this one. Second, the output, and the second one, and the third one. And there you go. This is the overall practicum 11, which is basically to determine the inverse Laplace transform. And that's it. Thank you, guys.